All right, this morning we are going to start Unit 5, which is our similarity unit. And I'm going to start here just with a couple definitions for you guys. A ratio is just a fancy word for a fraction, if I can spell properly. And a fraction is just relating two different values together. And I'm going to go ahead and insert a little equation here. Sorry, this is going to look bad. I don't have my paper with me. A proportion is what I'm typing right here. And that is, oops, let's do it like this, CD. So a proportion, all that is two fractions set equal to each other. So I just gave a little example with some variables here. A over B equals C over D. So those are two fractions set equal to each other. We're going to do a lot of focus today about solving proportions. And so to do that was where I put my next step here, cross product property, how to solve a proportion. So let me see if I can use this little inking feature here for you guys. So when you do what we call the cross products of a proportion, you cross multiply and divide. If you've ever heard about that, that looks terrible, forgive me. So cross products are diagonal from each other, and the word product means we're going to multiply. So cross products property is what you're looking at here with my little example. You can have A times D, those are diagonal from each other, equals B times C. And totally fine to flip that. We could do B times C equals A times D. Those both work. We can flip the letters around. We're just doing some multiplication. So your cross products, you're going to cross multiply. That means we're going diagonal. And then we set them equal in between. So we're just going to apply this to a problem here. The first example says a tight end scores 6 touchdowns in 15 games. If the player continues at this rate, how many touchdowns will he score in 25 games? Okay, there's multiple ways to set this guy up here. So I'm just going to start and I'm going to set up a little proportion. So he's going to make 6 touchdowns. And he does that in 15 games. Okay, to set up a proportion here that we can solve, what I need to do is I need to match the same units in the same part of the fraction. So it says if he continues at this rate, how many touchdowns will he score in 25 games? So I don't know the number of touchdowns, so I'm going to go ahead and put an X there. And then I do know I want to figure out how many he wants to, or how many he will make in 25 games. So this is the type of proportion I would set up here. So what we would end up doing for our cross products here, and you guys can see that I popped my calculator up here, but let me just go ahead and kind of write in my cross products, what I'm going to do here. So I'm going to cross multiply there, those two and those two multiplied together. So I'm going to end up with, let me type this out, you guys. We're going to end up with 6 times 25 equals 15 times x. Those would be our cross products. So I'm just going to grab my calculator here real quick so you guys can see it, maybe. There we go. So I'm going to do 6 times 25, that's 150. And then what I'm going to do is divide that by 15. So my answer here for x, it's going to be 10 games. I'm sorry, forgive me, 10 touchdowns. All right. Now, the rest of these examples here on the front are a little bit more straightforward. So what we're going to be working on is just cross multiply divide. So if I look at this first problem, when I do my cross products, I'm going to do x times 7 and 12 times 5. So we'd have something like 7x. 12 times 5 is going to give you 60. And then if you guys actually divide that, that's not a nice number. I'm going to pop my calculator up here. If I do 60 divided by 7, you can see that's kind of a nasty decimal there. So I'm just going to go ahead and round it to the nearest hundredth, which is 2 decimal places if it's not a nice number. So I'm going to say here x is going to be 8.57. And then we'll just continue on over here to this guy. Okay, 5x times 8, I'm going to multiply those numbers. That's going to give me 40x as the cross product. And 4 times 35, if you multiply that out, that's going to be 140. And so to solve that, I'm going to end up doing 140 divided by 40. So I'm just going to type that in my calculator real quick. And I'm going to end up with 3.5. So for this one, x equals 3.5. All right. Now down here in example 3, this is a little bit trickier. We are going to do our cross products here again, but you've got something a little more complicated in this problem. So I've got cross products, and anytime you have more than one term, I have a y plus 3 here in this one, put that in parentheses because you're going to need to use the distributive property to do the question properly. So for my cross product there, I'm going to go ahead and do 4, and then in parentheses I'm going to put y plus 3 because we're going to do a distributive property. My other cross product is just 8y. And then we're just going to solve this like a normal equation. 4 times y would give me 4y, and then 4 times 3 would give me 12. That's equal to the 8y. What I would do here, I'm going to subtract 4y, and I'm going to try and line that up with the 8 the best I can to make it look decent for you guys. So minus 4y, we'd be left with 12 equals 4y, and then I'm going to divide by 4. So 12 divided by 4 is going to give us our answer being y is equal to 3. Alright, just going to do that again over here in this question real quick. Now, when you guys do these products, cross products here, like I said, especially if it's got 2 terms, you want to put the terms in parentheses because you're going to need to distribute your cross product. So for this question, here's what we're doing. I'm going to do 18 times n, and then I'm going to do 6 times n plus 6. And then from there, we're just going to do a little distributive property. So 18n, this would become 6n plus 36 when I multiply the like terms there. And on this question, I like to keep my variable positive if I can, so I'm going to subtract that 6n to the side where the 18 is at. So if I do that, we're going to get 12n. That'll be left with the 36 on the other side. And then if you divide both sides by 12 to get the n alone, we're actually going to end up with 3, just like we did on the last question. Alright, I'm just going to move this next example down a little bit so I have some more space. Another type of question you guys might run into here. This is an architect makes a scale drawing on a floor plan for a home with scale 2 inches to 3 feet. So let me just highlight that real quick because we're going to need that. What would the dimensions of a 14-foot by 10-foot bedroom be? This question is really 2 problems in one. So it's not hard to do. We're going to set up a proportion real quick. Let me grab my fraction. Alright, and I'm going to set this so it's on this side of the problem. Okay, here's what you want to do. Set up your scale. You have 2 inches representing 3 feet here. Okay, now I'm just going to convert one side of this bedroom at a time. What you want to do when you set up a proportion is match the same units up in the same parts of the fraction. So I know the dimensions of this bedroom in feet. It's 14 feet by 10 feet. So I'll just start with the 14. I'm going to match that up in the same part of the fraction with the feet in the scale, and then I don't know how many inches this is going to be. That's actually what the question's going to ask me. So when I do my cross products here, I'm going to do 2 times 14, and that's going to be equal to 3 times x. You don't need to do any kind of a conversion here. This will just give you the answer. This is 28 equals 3x, and so to get my answer, I got to divide 28 by 3, which is not a nice number. So we've got 9.3 repeating, or 9 1/3 is another way to write that. 9.33 I'm going to write inches on that scale model. Okay, now I'm going to repeat this process for the other side of the bedroom. So I'm literally just going to copy this guy, except he didn't paste where I wanted it to. Okay, so the only thing I'm going to change up here, the other side of the bedroom is 10 feet. So the cross products will be extremely similar. It's just going to be 2 times 10, still 3 times x. So for this side of the bedroom, 20 equals 3 times x. So I'm going to grab my calculator and do 20 divided by 3, maybe. And that's going to give me 6.6 repeating. So let me just go ahead and round that. It's actually 6 2/3 as a fraction there, and those are the dimensions of your bedroom. So in real life, 14 feet by 10 feet. On the scale, it would be 9 1/3 by 6 1/3, or we just went ahead and rounded with the decimals there. Okay, now this example here is going to relate to examples 5 and 6 are going to go together. So I know you guys probably haven't done this in a while, so that's why I want to review this. We're going to do some factoring, and these are probably some of the more difficult questions that we'll do in this unit. But I just want to remind you a little something from Algebra 1. This is called a quadratic trinomial. I'm going to do ax squared plus bx plus c equals 0. So you guys solved questions like this in Algebra 1, and I'm just going to teach you my little trick for doing this. I'm going to write these equations in factored form. Okay, so these values become important. What you want, you need two numbers that when you multiply, sorry if I can spell, you get the c value, and the same two numbers add to get you the b value. Okay, this is how we're going to factor this. Alright, so in this question I've got x squared minus 8x plus 12. What your factors are going to look like, you'll have x and then x, something like this. And you got to fill these factors out. Like if I FOILed this back, I'd get x times x, I'd get x squared. Now, all I have to do to fill in for this particular question, I'm going to grab a different color. I need two numbers that when I multiply them, I tell you what guys, let me see if I can do this better. I need to multiply here to get 12, which is the number on the end. And I need the same two numbers to add to give me the number in the middle, which is negative 8. The only two numbers that are going to fit both of those requirements. Multiply to get a positive number, add to get a negative number, we're going to have negative 6 and negative 2. So when you fill this in, one of these is a minus 6. Sorry guys, this looks really bad. I wish I could just write it for you. And minus 2. Those would be your factors. If you were to multiply this back out, we'd get x squared, we'd get minus 2x, minus 6x, and then we'd get plus 12. Now, if I'm setting up this quadratic in this format, it makes it easy to solve it. If the equation's set equal to 0, I just want the number I could plug in for x to make that 0. So for this first set of parentheses, if I plugged in positive 6, that would make the equation true because it would make that first parenthesis 0. Here, if I plug in 2, it's going to make that equation true. So the two answers to this question here, solved by factoring, are going to be the 6 and the 2. Okay, let's see if we can do this for this question over here. I need two numbers that when I multiply them, we're going to get, let's see, the number on the end, which is negative 40. And I need the same two numbers to add to get me the number in the middle, which is negative 6. Okay, so to do that, multiply to get negative 40, add to get negative 6, I'm going to use x minus 10, and I'm going to use x plus 4. If I multiply those two numbers, negative 10 times 4, that'll give me negative 40. If I add those two numbers, it gives me negative 6. So it fits both of the requirements there. So that's the factored form. And then my two answers, all I got to do is tell what would plug it in for x, make that 0. This one's going to be 10. This one's going to be negative 4. Now, the reason we're just reviewing this a little bit is because we're going to end up solving a proportion that requires us to do this with our cross products. And so that's what's going to go on here. Let me come down to example 6. Okay, now the whole reason I was reviewing that with you is because you guys are going to see a couple questions like this where you've got to practice solving a proportion, but it's going to require us to do some skills from Algebra 1. So for this first question, my cross products end up being k plus 3 times k minus 2. Now the other side of the equation is just going to be 8 times 3, which is 24. Okay, now you can go ahead, if you guys remember doing this in Algebra 1, we're just going to do a FOIL. Now I just think of this as a double distributive property. So I'm going to multiply k by both of those terms, and then I'm going to multiply 3 by both of those terms to start this process. Whoops, let me come over here. Alright, so k times k is going to give you k squared. And then I'm going to do k times negative 2, so minus 2k. Then I'm going to multiply 3 by both of those guys, so it's going to become plus 3k. And 3 times negative 2 is going to be minus 6. We're still equal to the negative 24. Okay, so let me just simplify just real quickly. Negative 2k plus 3k is just plus 1k minus 6 equals negative 24. Now, what you want to do here, let me see if this will do this. You want to set this equal to 0. So what I'm going to do here is I'm going to add the 24 to both sides of that equation. We're going to get k squared plus k. And if I add 24 to negative 6, I'm going to get 18. Whoops. Guys, forgive me. I don't know where that negative came from. I don't know what I was doing. I think I was thinking about subtracting it. Okay, forgive me. We are going to subtract 24 from 6 to set that equal to 0. So this is going to be negative 30. And what I want here to do factors, I need two numbers that when I multiply them, I am going to get negative 30. And the same two numbers, when I add them together, I need to get the number in the middle. It's just going to be 1. So I'm going to say to you, those two numbers are going to be positive 6 and negative 5. If I multiply those up together, we're going to get negative 30. If I add them together, I get k. And if I've got them in this format, I just need to write my two answers. It's what would plug in for making that 0. So negative 6 and positive 5. Okay, I'm going to try and do this one more time for you guys. Cross products here, x plus 5. And then we're going to multiply that by x minus 2. And the other side of that equation is just going to be 5 times 6, which is 30. Okay, now I'm going to do my FOIL, or double distributive properties, how I like to see it. X times both of these terms, and then I need to do 5 times both of these terms here. And so I'm going to get x times x is x squared, x times negative 2 is negative 2x. 5 times x is 5x, and 5 times negative 2 is negative 10. That was equal to 30. Okay, just going to combine some like terms here. X squared, negative 2x plus 5x is 3x, and then minus 10 equals 30. Okay, again, like that last question, I want to set that equal to 0 before I try to do any factoring. So if I have negative 10 and I subtract 30, that's going to be negative 40. Okay, now what I want here, I need two numbers that when I multiply them, I get negative 40, and then the same two numbers I need to add to get the 3. There's only two numbers that'll fit both of those requirements, and that's going to be, we're going to do positive 8 and negative 5. That fits both of those requirements. If I multiply these together, I'm going to get negative 40, but if I add 8 and negative 5, we'll get 3. If you can fit both of those requirements, then you got your two factors. My actual answers to the question, negative 8 here and positive 5 here. It's what would set the parentheses equal to 0. Okay, no, that was the long example. I have one more example, and this one's actually going to be kind of quick. So what I have in example 7 is some ratios for some figures, and this is not going to be drawn to scale, but I'm just going to sketch you a little something. This says the ratio of the measures of the sides of a triangle is 3 to 5 to 7, perimeter is 450, find the measure of each side of the triangle. Okay, so I'm just going to draw, this looks really bad, sorry guys, pretend this is a triangle. And what I'm going to do here is, all you do if you have a setup like this with this ratio, you just attach an X to each one of those values. So I'm going to see if I can kind of use my finger a little bit here. Nope, I guess not. It's not going to let me. So I'm just going to say this is 3X, just for one of the sides, it doesn't matter. Call one of the sides 5X. And then the other side 7x. So I'm just using the ratio they gave me. Just attach your favorite variable, and that's all you have to do. Now, to set up an equation here, we don't know the side lengths, and that's what we want to figure out. I'm literally just going to add these together. So we have 3x plus 7x plus 5x, and I'm going to set that equal to the perimeter, which is 450 centimeters. Now, all I have to do for my next step, and I just broke that triangle apart doing that, sorry. All I have to do is combine like terms. So add those x's up, we get 15x equals 450. And I'm going to grab my calculator here real quick again. 450 divided by 15 is going to give us x being 30. And if I want to find the side lengths here, I need to just plug that back in. So 3x, that side, is going to end up being 3 times 30. And I'll just grab this. So this side, 3 times 30 would be 90. 5 times 30 would be 150. And 7 times 30 is going to be 210. And if you guys want to check that out to make sure it adds up to 450, 90, 150, and 210, it should check back out to add up to the perimeter they gave us. Okay, one more quick question. Ratio of the measures, the interior angles of a triangle are 5 to 7 to 8. Okay, now similar question, different though, because we're talking about angles. I'm going to do the same thing here. This is not drawn to scale. I'm just going to take each one of the numbers in that proportion and I'm going to attach an X to it. This time we're representing an angle. And in this question, different than the last, where it gave us a perimeter, doesn't give us anything here. So the key to this question is for you guys to remember what the inside angles of a triangle add up to, which is 180. So I'm just going to add these together. 5x plus 7x plus 8x. We're going to set that equal to 180 because the interior angles of a triangle add up to 180. Add those up. You're going to get 20x equals 180. And so x is going to be 9. And if we want to plug that back in to get our actual angle measures to check, let me grab a different color and we'll be done. So 7 times 9 is going to give you 63 for this angle measure here. Eight times 9 is going to give you 72. And 5 times 9 is going to give you 45. So I have my 3 angle measures there, and those 3 should add up to 180.